Namaste. Once again, welcome to the tutorial. In this tutorial, I will be talking about Lagrange interpolation. First of all, I think you know well about the interpolation. Actually, interpolation is a method of finding the values of the function in between the two given points. Okay, so there are a few points given. With the help of those given points, we need to find the functional value or function value of variable between those given points. Okay, so that is interpolation. So to find the value right outside the given point is extrapolation, but in this method I will be talking only about interpolation. Actually, Lagrange interpolation, you know, in Newton's method of interpolation, the interval should be of equal width, otherwise we cannot find the interpolated value. That's why Lagrange method is quite more useful than that of Newton's method. Okay, so first of all, I'm not going to going on the details of Lagrange interpolation, so I will just simply give brief introduction only. This is the functional value at which we want to find the we want to find the interpolated value. Well, this is L and this is Y. Alright, so yes, L is nothing but this equals 1 if I equals J, and equals 0 if I not equals J in here. Okay, but here actually this Ln comma J equals, this is the formula. So x minus xk over xj minus xk, which is multiplied from 0 to n. Okay, so yes, this is the value of L. Make sure we will write the same formula in our Fortran code, so please do remember this: x minus xk over xj minus xk, and multiply, it is done multiplied from actually k from 0 to n or simply from 1 to n, no problem on that. Alright, so yes, it is from 1 to n in my formula, not from 0 to n. Okay, so yes, for multiplication, you know, in Fortran code we will use do loop. So we will first of all multiply value of k as 1, and then we substitute that as L, and again we find for k equals 2, and we again multiply that. Okay, I will explain this later, but make sure this is L, and L while multiplied with Y and summed over j runs from 1 to n in my formula, not from 0 to n. Okay, so this gives the interpolated value. Alright, so this is what our formula is, and question seems to be like this. Well, see, and these are the value of x, and these are the corresponding value of y, but we have to find a value of y at particular value of x within inside minus 1 to 2 or 3 to minus 6. Okay, this is what I am going to deal with. Alright, so yes, now we will see examples later, but this is the generalized formula. Simply we will use this formula, and then yes, I want to repeat this again because this seems quite yes, first of all we will find L, and then we multiply that L with y or function of x, and finally we add this thing. Alright, so make sure you know these 2 points. You will simply understood how yes, Lagrange interpolation method can be used. Okay, so let us move to the code in the Fortran. For that we need to open terminal by using Ctrl+Alt+T, and yes, so our terminal will open. Yes, this is what our terminal is. Okay, now let me go to the desktop. Let me go to my folder where I want to save the file. yes, I think for YouTube will be my folder. Well, so I will use Gini as my document editor, and yes, and I will name the file of my Fortran code as Lagrange lag only Lagrange dot f90. Yes, to run this terminal in the background, I need to add end here. Okay, now my Genie will open. Yes, this is what my Genie is. So you know the format of the program Lagrange, yes, Lagrange, and this is the format of the program. Alright, so we should use implicit none, real, integer. To find more precise value, we can use double precision instead of real. There is no problem on that. Alright, so yes, simply we can do that. But here, as I showed you, question would be of this format. So we want to introduce array on our Fortran code as xi, and we want to introduce array on our Fortran code as yi. Two Fortran codes, okay, sorry, two arrays. So for that, you know what we do to create array. We will use real external, sorry, not real external, real dimension. We want fixed dimension here because we can we can solve any questions later by using different numbers of arrays. So we don't fix dimension yet. This double is to gives the dimension later. For that, we need to introduce allocate table also. Allocatable. Okay, so allocatable will be, as previously I said, we will have x as our array and y as our array. So we write x comma y as our allocatables. Okay, so yes, now decorate this by saying welcome to this program created by Giri, Mohan. Well, you know my name. Okay, now what we do is, yes, first of all introduce how many integers or how many number of members in each array we are going to introduce. For that, we will give input each time, because while fixing yarn will limit our program to only a particular problem. But if we give input in each step, then we can get answers for any questions that we are asked. Alright, so yes, and let us write print, please insert the number of dimension of array, or simply you can say number of data points. Okay, so simply you can say this. So we should read this as yan. Alright, so we need to introduce yan as an integer parameter. So we give yan. Now what we do is we will give input for x and input for y. For that, what we're gonna do is, yes, first of all, we should define dimension of x and y, because we have not defined dimension yet. So for that, what we do is we will allocate. So we read yarn now allocate. This is the format of allocate. Yes, so we allocate x as nth dimension. Similarly, we should have equal number of dimensions in x as well as y. So we can copy this and we can paste this over here and replace by y. Don't be confused over here. How this works is, we have not fixed dimension of this array 1 2 3 4. Okay, its dimension is 4. We have not fixed that yet, so we will give input as 4, and finally after giving input, yes, x will be assigned as its dimension as 4, y will be assigned as its dimension as 4. Alright, this is how we allocate the dimension of the array. Now what we do is we give input for we will give input of all these numbers. For that, what we do is first of all, to introduce anything in the matrix or array, we need to use do loop. Alright, so do I runs from 1 to n, and this is the format of do loop. Alright, so yes, I is not introduced, whether it's real or integer, this should be integer. Alright, yes. Now what we do is read as x I and y I. So what this is doing is, first of all, we assign dimension of x and y, and after then computer will display what it display is, please insert the value of x and y and its corresponding y respectively, yes, and this will be displayed on the screen, and then we start do loop to give our input up to from I equals 1 to n. So we should give two input at one time. For I equals 1, we should give another inputs for I equals 2, and so on for up to n, and we have given input so far. Okay, now we gave input for this. Now what we do is we set this formula. Alright, yes, first of all we set this formula, and then we will add up all those things. Okay, as you know, yes, this is the pi means multiply, so multiply all values of for all values of k. So for that, what we define is we use do loop. Alright, so far we have given input. Now first of all we define L equals 1, then only we define do loop from I. Okay, we can use the same variable as in our formula. So this is for k. Okay, so variable is for k, and for k not equals j. For that, what we do is we define L equals 1 for our initial value, and for k equals j, the value should be n. Alright, 1. So that's why this is L equals 1. So let us introduce this do over here. Do I runs not always I, we will use which k, we will use k here. Okay, so k runs from 1 to n. Alright, so first of all L equals 1, and this is the format of the do loop. So actually L equals 1, but if we do have k not equals j, then it should give this value. So let us define that condition. L equals 1 generally, but if this is the format of if. Okay, sorry, I have not completed the format. If this is the format of if, so if what we have defined is k not equal to j, then we to have our formula as L equals L. Okay, don't be confused. For multiplying things for each value of each value of k, we need to have yal equals yal into that formula. Don't be confused. This only for getting a multiplied value of this. Okay, so x minus xk divided by xj minus xk is the formula. To divide by, yes, this is our format. X okay, so first of all, what that x means, try to understand. This x is the value of x at which we want to find the value of y. Okay, that's why I will define this x as xj given x given minus xk. You can simply see same thing on the figure in the formula, xj minus xk. Okay, so divide by xj minus xk. Okay, so this is what we defined yal or multiplied form of this. Now what we gonna do is we will multiply this yal by y or f of x and then add up all those things. Okay, so yes, it's simple, and finally we will get answer. So yal multiplied by y and sum of all those will give our answer. So yes, so for that what we gonna do is, first of all, we define sum equals 0. Alright, and what we do is, to do sum of all these things, we again start do loop in here. Alright, so do loop equals do and here we have introduced j that runs from 1 to n. Alright, yes. So this is what our program is, and we have to if is here. Okay, so we started do for j, and then for all value of yal we will add that. Alright, so we should write sum equals sum plus, see what our formula is, y into yal. Okay, so y is nothing but okay, first of all let us write yal into y is nothing but yj. Alright, because we are summing for j as a y. Alright, so yes, once again I want you to see the formula very carefully. First of all, multiply yal by x and then add all the value of that multiplied form. What we do is, first we define sum equals 0, and then sum equals sum plus this. What this gives is, for the j equals 1, this sum would be 0. Okay, and okay, it will find yal into yj, and then that will be the sum 1. Now for j equals 2, yes, this would be sum 1, and yes, this is nothing but the formula sum 1 plus this gives sum 2. Again, for j equals 3, this would be sum 2, and we can find sum 3 by again using the same concept. This is how we can add all those values from here. That means we can get summation. Okay, this is how we can find interpolated formula. Well, so I have used yal over here. I can move this yal from here to here as well, because yes, while doing do loop we first define its initial value right outside the do loop. That's our convention, but still what we did was correct. Okay, yes, this is how we can do. Now we should print the answer what we did. Okay, the interpolated value at yes, xg is what sum. Okay, that would be our answer, right? So no problem. But one thing, xg is the value of x at which y is to be calculated. So we need to give input as that as well. Okay, so for that we can do in here. And yes, next thing is we have not finished do loop, so please don't forget this do loop in do for this j variable. Okay, not for k variable but j variable. So we have done this. Now what we do is, let us give input as print please value of x at which y is to be interpolated, right? So it should be written as ext. You know well about this format. Okay, now let us check what things we have used. First, ext should be defined as real. X and y are already defined, n is defined, I is defined, j and k are not defined, they are real variable. Okay, so yes, yal is not defined, yal is, sorry, j and k are integers, eh? Yal should be real, and sum, yes, you can see here, sum is not defined, so please define sum here. Yes, so now we can check, but still let us find whether we have left something over here. Ind is also indent, and do is indent for j, and similarly do is indent for k. No problem, we are printing the value right inside. Okay, for all value of, sorry, yes, so if we want to find for all values, then only print inside the do loop, otherwise it should be right outside the do loop. So we can do this outside the do loop. Now only one answer would be obtained. Okay, yes, this is how we can do. Let us check whether we do have some errors. Yes, of course there is no any error, but let us check whether we can get the right answer. Now please insert the dimension, but first let us see the question. Yes, okay, and then only we can find answer. Yes, and let us make it small. Yes, please insert the number of data points. How many data points we do have? 1, 2, 3, 4. Yes, so insert 4 here. Please insert the value of x and its corresponding y respectively. First of all, we do have -1 and then a y3. Similarly, sorry, number of, please insert the value of x and its corresponding y respectively. Wait a minute, maybe I got some errors in the code. Please insert that the value y is to be interpolated, and sorry, I inserted this right inside the do loop. That was what our mistake was. Okay, I should be written this. Alright, so now everything would be fine. Alright, so yes, let us check our answer now. Yes, let us make it simple, small. Yes, oh sorry, and then yes, so we do have 4 data points. Insert 4 here. Now value would be, first value would be -1, and then its corresponding is y. Similarly, second would be 0 and its corresponding y is -4. Third would be 1 and its corresponding y is 5. Similarly, value is 2 and its corresponding is minus 6. Okay, so at which value of x we want to find y? So let us have the same what this book is doing. All right. Okay, the question is, where is the answer? No answer. Oops. We choose this question just to check whether we are right or not. Okay. Yes, and we will use Lagrange interpolation to find the unique polynomial. Okay, we are not finding unique polynomial. Let us find value in between -1 to 2. Yes, we can find the value of y at 1.5 right in between these two, no problem. So let us have value 1.5, and yes, at 1.5 y should be 4.25. okay, for your convenience we can check another example as well. For that, let us run this again, and yes, so we will use 4 data points. Okay, please insert the value. Okay, we will check square function, and we simply know the answer. Alright, so yes, please insert the value of x at its corresponding y is to be found. Alright, so first of all, let us insert 1 and its square is 1, 2 and its square is 4, 5 and its square is 25, and 7 and its square is 49. Okay, now we want to find at 6 what would be y. Okay, yes, so at 6 value of y is 36. 6 square is nothing but 36. So we can find any number, we can find solution that is y in between 1 and 7 as value of x. Simply I calculated square of 6 as 36. See, simply this is how Lagrange interpolation works. But make sure you understood. Okay, there are 3 parts on this program. I would like to repeat that once again. This is just for designing. Okay, first of all, what we do is we define x and y as our array, but we left the number of dimensions because with the same program we are supposed to find any type of problems. Okay, so that's why we didn't fix the dimension. All right, so yes, for fixing dimensions, first of all we give the input as n, and then for fixing dimension of x, we use allocate x, n and bracket. All right, so this is the function. This is for yes, fixing the dimensions. All right, so now this is the second portion. Second portion includes inserting the arrays. Okay, so inserting the value of x, inserting the value of y for all values of x and for all values of y. And this is what we do for inserting all values of x and all values of y. Same format, print, please insert that and then read. But to read many values we are using do loop. Okay, that's what we are going to do. And then in the next portion we give input for at which we are supposed to find y. Okay, that's what we did. And yes, the last portion, but not the least, very easy one, is first of all, yes, let's forget this j. First, yes, here is what we do. First of all, we find multiplication part, as our formula is here. This means L, we found L, and then finally multiply by FC. and for yal, first of all yal will be 0, and then it will be started to find something. So yal equals yal into this and this. Alright, and then yes, to multiply each value means this, we are using yal equals yal into this only for k not equals j. See, see this k not equal to j in our formula. Alright, so yes, this is for finding yal. Now to multiply that yal by y and summing over yes j, to multiply that yal by y and summing over j, what we do is we first of all define sum equals 0, and then yes, to do summation we use do loop for j equals 1 to n, and then define sum equals 0 for j equals 1. This sum would be 0, and then this is how yes, this is for summing. Alright, sum would be this one and this. Okay, this is how, and finally we printed the answer here. Okay, this is how one can find Lagrange interpolation. Thank you so much for watching this video. Please do say something about this work, and I'm sorry for my English and I'm sorry for my accent. Thank you so much.